Hi, we continue chapter 3, electromagnetism. So today we discuss topic 3.4, transformers. So what is transformer? The word transformer comes from the word transform, meaning change something. A transformer is an electrical device which increases or decreases an alternating voltage based on principle of electromagnetic induction. I hope you still remember what is concept of electromagnetic induction. Okay, describe the structure of simple transformer. So this is the structure of simple transformer, and this one is electrical symbol for transformer. A transformer consists of two coils of wire wound around separately on a laminated soft iron core. So you have two parts of coil of wire. This part we call it primary coil, and this part is secondary coil. The coil connected to input voltage, that is alternating voltage, is called primary coil. The coil connected to the output voltage is called secondary coil. So for secondary coil, it can be connected to a load or resistor or a bulb. Okay. The purpose of common iron core is to provide magnetic field linkage in the secondary coil. So the shape like this in order, when the current flow in the primary coil, the soft iron core magnetizes and causes the magnetic flux linkage through the secondary coil. Okay, now we want to explain the operating principle of simple transformer. So a transformer works on the principle of electromagnetic induction. What is electromagnetic induction? Okay, last time we have discussed that. When there is a relative motion, there will be change in magnetic field. The change in magnetic field will produce induced EMF or induced current. Okay, now look at how the induced current is produced by transformer. When AC voltage Vp or primary voltage Vp is applied to primary coil of transformer and alternating current flows through the coil, the soft iron core is magnetized in one way than the other. Because you know that alternating current, the direction of current keep changing every half cycle. So meaning the magnetization is also in one way and then the other way. Okay, so keep changing direction of magnetic flux. So this means that the magnetic flux linkage in the secondary coil is constantly changing. So that's the reason why the magnetic flux linkage also constantly changing. So due to the alternating current that keep changing every half cycle. An alternating EMF is induced across it to produce an AC voltage Vs, secondary voltage. In secondary coil, an AC current flows through the second coil. That is the induced current flow in the second coil. The frequency of the secondary voltage Vs is same as that of primary voltage Vp. So they have Vp and Vs same frequency. The magnitude of secondary voltage, that is Vs, depends on the ratio of number of turns of primary and secondary coil. As we know, factor that affect induced current or induced EMF, that is stated by Faraday's law. It states that one of the factor is number of turns of the coil. The more the number of turns of the coil, more magnetic field lines will be cut, thus produce higher or larger induced EMF or induced current. Okay, we continue next page. Okay, now, as you know, for the primary coil always connected to alternating power supply. So why does transformer not work with DC power supply? Let's say if you connect the primary coil to direct current power supply like a battery or dry cell, so what happens? A current is induced in secondary coil only when there is a changing magnetic flux due to changing primary current or changes direction and magnitude. A direct current power supply gives a constant current in primary circuit. A constant direct current whose magnitude and direction is constant does not create a changing magnetic flux in secondary coil. So meaning if we use the direct current, the magnitude constant, direction constant, so the magnetic flux linkage does not change in the secondary coil. So there will no change in magnetic flux. So no induced EMF or no induced current. That's the reason why we cannot use DC power supply. Okay, now we want to produce formula to state relationship between Vp, Np, Vs and Ns. Okay, so the Vp is the primary voltage, Np is the primary coil, number of turns of primary coil, Vs is secondary voltage, Ns is number of turns of the secondary coil. Okay, now we have discussed before, according to Faraday's law, voltage is directly proportional to rate of change of magnetic flux, and the rate of change of magnetic flux depends on number of turns in the coil. Thus, we can say voltage is directly proportional to number of turns in the coil. So here we have V directly proportional to N, or V equivalent to Kn, where K is constant. Thus, V divided by N equals to K, that is constant. Meaning the ratio of V to N is always constant. So when we discuss about primary coil and secondary coil, we take a ratio, so we get Vp over Np is equals to Vs over Ns. So the ratio is always constant. Okay, so this one we have defined already. Okay, now we look at the symbol for the transformer. This is the electrical symbol. So remember, the primary coil is the coil that connects to the AC power supply. The secondary coil is the one connect to any load, resistor, a bulb, or maybe a ammeter or galvanometer. Okay? Meaning this part there's no power supply. So it's quite easy to differentiate between primary coil and secondary coil. Primary coil, there must be power supply, AC power supply. Secondary coil, there's no power supply because the current produced by induction in secondary coil. Okay, now because we know just now V is directly proportional to N, that means we can change the value of voltage by changing the number of turns. Okay, so we can produce two types of transformer, the step up transformer and step down transformer. If Ns is greater than Np, means number of turns in the secondary is more than number of turns in primary, then Vs is greater than Vp. So here we can Ns greater than Np, so Vs is greater than Vp. So step down transformer, Ns is less than Np, thus Vs less than Vp. So transformer can be used to increase or decrease the induced EMF produced, or the voltage of the alternating voltage. Okay, now we look at the next page. Okay, here the symbol for step-up transformer. So you can see the number of turns for the Ns is more than Np. So this one we call it step-up transformer. For the step-down, you can see the Ns is less than Np. Okay, now we want to relate between output power and input power of an ideal transformer. What is the meaning of ideal transformer? It's a perfect transformer, meaning no energy loss, 100% efficient. 100% efficient. Meaning all the power that's supplied to the input or primary coil, okay, is equals to output power in the secondary coil. Okay. So transformer transfers electrical power from primary circuit to secondary circuit. The primary circuit of transformer receives power at certain voltage from AC power supply. The transformer delivers this power at another voltage to electrical device connected to secondary circuit. Okay, so the primary has the power supply, so this one we call it input power, that it will produce output power. So for ideal transformer, there is no energy loss during process of transforming the voltage. So meaning power supplied to primary coil equals to power used in secondary coil. Remember the formula of power, P equals to VI. So for the input power is the primary part, so we have Vp times Ip. And the output power is secondary part, so we have Vs Is. Thus we have this relationship, Vp Ip equals Vs Is. So from here we get Vp over Vs equivalent to Is over Ip. So this relationship just valid if the transformer has 100% efficiency or ideal transformer. So from here you can see when the step-up transformer is used, meaning Vs is greater than Vp, then the Is is smaller than Ip. So higher voltage produced, the induced current is smaller. Okay. So now we want to discuss again, because we know in the real life we cannot find 100% efficient. There's always energy loss. So we want to describe energy losses in a transformer. In a real transformer, some energy is lost in transformer, especially in the form of heat. The output power is less than the input power because some of the power loss. Therefore, efficiency is less than 100%. Okay, so that one is efficiency. I think you still remember efficiency we have discussed in form 4 also. So efficiency equals to output power divide by input power times 100%. Or you can write in the symbol, output power, PO over PI times 100%. Remember what is PO? PO is the secondary part. So we have VS, IS. The input is the primary part, so VP, IP. So times 100%. Okay, so we have this formula for efficiency. So for transformer, the power loss is due to 4 factors here. Heating of the coils, eddy currents in the iron core, magnetization and demagnetization of hysteresis loss, leakage of magnetic flux. Okay, now we want to discuss the causes of energy loss and ways to improve the efficiency of transformer. So normally discussion will come out in AC part, section B or section C. Okay, look at the first point, resistance of the coil. So all coil will have resistance. Heat is produced when current flows through them. Remember, when there is a resistance, there must be work done to overcome resistance. So the work done will cause some of the energy will be converted to heat energy. So that will be lost. So ways to improve efficiency of transformer. So instead of using thinner copper wire, so we use thick copper wire. Because for thick copper wire, resistance is smaller. Okay, so less work done to overcome resistance, so less energy loss. Okay, second, eddy current in the core. The changing magnetic field will also induces current in the iron core. This induced current is called eddy current, cause heat to be produced in the iron cores. Okay, so normally we just discuss that there will be changing in magnetic field lines that link to the secondary coil, but at the same time there will be some of the changing in the magnetic field that occur in the core itself. So the change in magnetic fields in the core itself will induce a small current that we call eddy current. So this eddy current will cause heating of the iron core. So the energy will be lost in form of heat energy. So how to reduce eddy current? So we use laminated cores. Meaning instead of using one block of iron core, we can cut the block into thinner pieces of iron core and then join it back. So it becomes laminated cores. So each of the layer or thinner pieces of the core will have higher resistance. So meaning the overall iron core, laminated iron core will have higher resistance. So the higher resistance will reduce eddy current. Okay, magnetization and demagnetization, or some say as hysteresis loss. The alternating current flowing through the transformer continually magnetizes and demagnetizes the core. Work has to be done to change the magnitude and direction of magnetic field in the core, which contributes to energy loss. So the process of magnetization and demagnetization also need work to be done. That's why some of the energy also will be lost. Okay, so how to overcome the problem? Use cores made from soft iron core. So because soft iron core can be easily magnetized and demagnetized, meaning less work done needed for the process, so less energy loss. Okay, last point, leakage of magnetic field. Electrical energy is lost when fraction of magnetic field produced by primary coil does not link with secondary coil. Okay, so you can see for if we use the basic structure of the transformer like this. So we have primary coil here, we have the secondary coil here. So you can see once the current flow in the primary coil, it will magnetize the iron core in the one direction and then keep changing. So the flux linkage to the secondary coil. But what happened is some of the flux line does not link to the secondary coil. So this part we call it leakage. Okay, so the leakage will cause the induced EMF produced is a bit smaller than it should be. So there is a leakage of magnetic field or electrical energy loss. Okay, so how to overcome this problem? What we do? Wind the secondary coil on top of primary coil. So below at the bottom we put the primary coil, then on top of the primary we just wind the secondary coil. Meaning automatically we can say maximum of the flux line will be linked to the secondary coil. So we can reduce energy loss due to leakage of magnetic field. Okay. Okay, now let's solve some of the calculation problems involving transformer. So there's a formula, there's always calculation problem. Okay, look at the first one. Transformer requires a step down. To step down the main voltage, okay, at 240 volt, provide a 12 volt supply for an electric coil. If the primary coil is wound with 1000 turn of wire, calculate number of turns required for secondary coil. So advisable for you to list down first. So the main voltage is VP. So you write down 240 volt. And then the VS, V1 is 12 volt. And given also the primary turns, NP 1000. So we want to calculate number of turns for secondary. So it's very direct. You have the formula just now. VP over NP equals VS over NS. Okay, we just substitute all the values in. 240 volt divided by 1000 equivalent to 12 divided by NS. So you do some of the mathematical calculation, so you will get NS equivalent to 50. Okay. Okay, number 2, a step-up transformer has 10,000 turn on its secondary coil. Okay, step-up transformer, secondary, so meaning NS is 10,000. 10,000. So you will have NP 100. So you have primary current, IP is 5 ampere. So you have VS, VP. VP is 12. Okay, now part A, the input power to the transformer. Input power is primary part, so VP, IP. Okay, so you just substitute the value. VP is 12, IP is 5. So you get P equals to 60 watt. Okay, so power input equals to 60 watt. Okay, question part B. The EMF induced across the secondary coil, meaning VS. So you have VS over NS equals to VP over NP. Okay, so VS, we want to find VS over NS. NS is 10,000 equivalent to 12 divided by 100. Okay, so what we get here, VS 1200 volt. Okay, so this is a step up, so that's why VS is more than VP. Okay, what is maximum current that could flow if the transformer 100% efficient? 100% efficient means power input equals to power output. Or we can say that VP IP equals to VS IS. Okay, so you want to find IS. So VP equivalent to 12, IP 5, VS you want to find. VS just now we have 1200 IS. Okay, so you calculate for IS, you will get 0.05 ampere. So you can see the value of IS is smaller as compared to IP. Because step-up transformer, it produces larger induced EMF. So the larger the induced EMF, the smaller, okay, the induced current. Okay, so that's all for topic transformer. You must go and do more exercise on this, especially the essay question. Okay, we continue next time.